Hello. Question 2 asks us to solve the following integral problems. Now for integrals, we're going to solve them very similar to derivatives, where we find the general form of the integral of the function given, and then we insert our numbers, or plug in our numbers, and we solve. So for part 1 of question 2, we need to find the integral from 0 to 1 of x squared plus x dx. Now the integral of x to the n is equivalent to 1 over n plus 1 x to the n plus 1. So what we're going to do is we're going to apply this rule, and we're going to get the range from 0 to 1 of x cubed 1/3. Let me rewrite that. Plus 1/2 x squared. And then we also need to add a plus c at the end because we're integrating, and we could have a constant that would disappear in our thing that we see up here. So we're going to evaluate this range. Well, if we plug in 0 for x, we just get 0. And if we plug in 1 for x, we get 1/3 times 1 cubed plus 1/2 times 1 squared minus 0 plus c. So we get 5 over 6 plus c. Now for the second part, we need to find the integral from 0 to 1 of 1 over x plus 1 dx. Now for this question, we need to remember that the derivative of log base e of x is equivalent to 1 over x. So by reverse, the integral of 1 over x is equal to ln of, technically we have to add an absolute value here, of absolute value of x. So we're going to apply this here. We're going to get the range from 0 to 1 of ln x plus 1 plus c. Now if we evaluate this, we get ln of 1 plus 1 minus ln of 1 plus c. In this case, ln of 1 is 0 because e to the 0 is 1. And ln of 2 is a number that we can just leave in this form. So our answer is going to be ln of 2 plus c. And that is question 2.